So we started chapter 14, and they're talking about binary number systems, octal number systems, and hexadecimal number systems. When you think about a computer and you like look into it with like X-ray vision, what you're gonna see are a bunch of wires, right, that are all just like interconnected, and you have little switches in there that kind of can form AND or OR gates. You might learn about that if you study computer science at the university level. But all a computer has to work with is an electrical current, right? And we have two states with an electrical current. We have on and we have off. And so when we're thinking about a number system that a computer can understand, we are talking about off with 0 and on with 1. Okay? And so what is the number system they can work with is a binary number system, right? We work with a decimal number system where we count up to 10, and then when we get to 10, then we start with 21, 22, right? But the 21 is a 2 and a 1, right? So it's still a part of the base 10 group of numbers, which are from 0 up to 10. So with a binary number system, we only have 0 and 1 to work with. So the first digit would be 2 to the 0. The second digit would be 2 to the 1. The next one would be 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, and so on. And so what is 2 to the 0? Well, you might say 0, but it is not. It is 1, right? Any number to the 0 power is 1. And then 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 2 times 2 times 2, which is 8. We get 16 and 32, right? What you can do here is you can start with a 1 and just double it every time you move on down to the left, right? And so these are the digits, the decimal value of the digits in a binary number system. So if I had 0, 1, 0, 1, 0, 1, as my binary number, I want to go ahead and convert that into decimal. How would I do that? I would add up all the ons digits, right? I would ignore the off digits. So I would add the 2 plus the 8 plus the 32, and that would give me 42, which is this number here in decimal. So this binary number is 42 in decimal. Okay, and so here we have a 5-bit number, and you might think back on Nintendo, like the first Nintendo. It was like an 8-bit system, and so that means that every digit that they represented had 8 bits to work with, and I think that's 256. It goes up to 256. Yeah, and then we moved on to 32-bit systems with like the Saturn and the Super Nintendo, and then we moved on to 64-bit systems. And same thing with computers, right? We had 32-bit systems a little while ago, and now we're moving on to 64-bit systems. And so that just means that the number of colors that they could represent increase, the number of digits in their number systems that they work with can become more exact, right? And so if you're thinking about an octal system, it's the same thing, right? We got 8 to the 0, 8 to the 1, 8 to the 2, and so on as we move on our way down, right? And if we even think about a hexadecimal system, that's from the 16th, right? So we got 16 to the 0, 16 to the 1, 16 to the 2, as we work our way down to 16 to the 5, or whatever last digit you have to work with. And so and so something that's strange about with an octal system, we go from 0 to 7. Well, 0 to 7, because that is 8 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, and then and with hexadecimal, we go from 0 to 9, which is 10 digits, and then when we get to 10, that's represented with the letter A. We get to the number 11, that's represented with the letter B. 12, C. 13 is D. 14 is E. And 15 is F. And that is 16 numbers, right? And so that's kind of the base of talking about these different number systems.